Ladies and gentlemen, thank you for joining us for the 24th edition of the World Sustainable Development Summit, India's premier platform for deliberating the discourse around sustainability and climate change. My name is Nathaniel. I'm a senior research scientist with Mugama, and I will be emceeing today's proceedings. We have a fantastic line of speakers for this session on science and policy action on reducing plastic and chemical waste in the marine environment. May I request Dr. Hans Nicolai Adam from NIVA to deliver the welcome address.
Thank you so much, Nathaniel. And thank you very much for coming for today's session. I can see we have a full room, so it's great to see the kind of interest that we have still in this very important environmental issue that we will be discussing later today. Dear Martine, Bottheim, Minister Counsellor from the Norwegian Embassy, Mr. VP Mishra, Joint Secretary, Ministry of Environment, Forestry and Climate Change, dear panelists, colleagues, it's a great pleasure to have you here today, so thank you very much for coming. My name is Hans Nicolai Adam. I'm a senior research scientist at the Norwegian Institute for Water Research, which is leading this project for the last 6 years, in fact. So we have been having a long-term collaboration with Indian partners and with the ministry and with the embassy. The session today on science and policy action on reducing plastic and chemical waste in the marine environment is hosted by the Indo-Norwegian cooperation project to reduce plastic and chemical pollution, in short, INOPOL. And we have been working, in fact, we just came from the field in Tamil Nadu, where the primary case study site for this project is placed. So we have been mapping the Kaveri River for the last 2 years with quite intensive field work. And the project is really trying to hit a knowledge gap that exists when it comes to data on macroplastic pollution, on microplastic pollution, and the kind of policy interrelationship. So we have been working closely with the Tamil Nadu Pollution Control Board, trying to build capacities to actually better understand the data that is needed, the data requirements, monitoring protocols. And we are very thankful for the support from the Royal Norwegian Embassy, which has been supporting this project over several years, as well as to the Ministry of Forestry and Climate Change, which has also been part of this marine pollution initiative. So thank you very much for your support over the years. We also have 5 partners as part of this project. That is Mogama, which is leading the Indian component. We have CIPET, and we have Toxics Link, and we have SRM University. The importance of this subject is really to understand both plastic pollution as well as chemical pollution and the interrelationship. And it's really kind of designed around providing rigorous scientific support to provide better policy in the kind of environment that we live in. And we do live, and one of the other important elements of this project is really the cooperation part, the cooperation and capacity building part. I mean, we do live in a time of a lot of uncertainty, a lot of acrimony. But these kind of collaboration projects between India and Norway are extremely important to tackle an international issue that is not based on national boundaries. So it's a cross-boundary issue. We have an exciting panel and presentations that will present some of the initial findings, some of the approaches, and some of the outcomes of this project today. So we have Dr. Rachel Hurley, who will be talking a little bit more about the macroplastic sampling and the fieldwork results, which we have been gathering over the last few years. And we have Professor Chakrabarty, who is a leading scholar in the field, to talk a little bit more about the chemical pollution component, followed by a panel by 5 experts from our partners. And of course, the important aspect, since this is a science-driven project, is the release of scientific reports that will be used when we think about policy making. So those will be releasing in the second half of this program. So I invite you all to participate in this program. There's also time for question and answers. And I thank you all for the interest to join and to actually participate in this kind of scientific work that we do. So thank you very much, and please feel free to approach any of us from the project also afterwards.
Thank you, Hans. May I request Her Excellency Ms. Martine Aamdal Bottheim, Minister Counsellor, Deputy Head of Mission, Royal Norwegian Embassy in New Delhi, to deliver her keynote address.
Dhanyavad. Namaste. Mr. Prakash Mishra, Joint Secretary, MOE-FCC, Hans Nicolai Adam from NIVA, Girija Bharat from Mugama, colleagues and friends, namaste. The blue economy is a topic that I am really passionate about. Not only because of the importance of the blue economy for the people and prosperity of my country, Norway, but also because cooperation related to the blue economy is and has been for a long time the backbone of Norway's cooperation with India. So I am very happy to be here today among colleagues and friends who have worked together for many years to address the issue of marine pollution. The embassy, as Hans mentioned, is very proud to support the Indo-Norway cooperation project on capacity building for reducing chemicals and plastic pollution in India, INOPOL. It is a collaborative initiative between the Norwegian Institute for Water Research, NIVA, Mugama Consultants, the Central Institute of Petrochemicals Engineering and Technology, the SRM Institute of Science and Technology, and Toxic Link. The overall objective of the project is to build knowledge and capacity to tackle plastic and chemical pollution from important sources within key industries, public sector, and civil society. In the current project phase, INOPOL aims to develop targeted, efficient, mitigative, and solution-oriented measures for the control and reduction of persistent organic pollutants and plastic pollution in Tamil Nadu. In 2019, Prime Minister Modi and the then Prime Minister of Norway elevated the bilateral cooperation between India and Norway regarding oceans. An MOU was signed which established a formal India-Norway ocean dialogue at the political level and a joint task force on blue economy for sustainable development at the working level to steer the dialogue and to catalyze cooperation in relevant sectors of the blue economy. The task force brings together ministries, research agencies, and private companies from both countries across a range of important issues relating to the oceans. It also includes initiatives to combat marine pollution and promote sustainable ocean management, guided by the Ministry of Environment, Forest and Climate Change in close collaboration with the Norwegian Embassy, and this is supported by a portfolio of specific collaboration projects. And the INOPOL project is one such project. The goal is that science-based knowledge will support India's targets to reduce plastic releases, to implement the Stockholm Convention on Persistent Organic Pollutants, POPs, as you all know, and to strengthen the central, local, and regional capacity to prevent and mitigate the environmental threat posed by plastic and chemical pollution. The INOPOL project is a good example of thinking globally, acting locally. Because marine and plastic pollution is a major global challenge. And as we are all aware of, countries have been negotiating an internationally legally binding treaty on plastic pollution, including in the marine environment, for the last 2 years. And we are very hopeful from Norway's side that we will get this treaty this year. I am glad that both Norway and India are actively participating in the International Negotiation Committee. A group of like-minded countries has created the so-called High Ambition Coalition to End Plastic Pollution. This high ambition coalition is co-chaired by Norway and Rwanda. The High Ambition Coalition is committed to develop an ambitious internationally legal binding instrument based on a comprehensive and circular approach that ensures urgent action and effective interventions along the full life cycle of plastics. Domestically, in Norway, we have developed a plastic strategy. This strategy includes measures for more sustainable plastic value chains and measures to ensure that hazardous substances are removed from the cycle, which will increase recycling of plastic waste and ensure safe new products. The strategy points out that a more circular plastic economy must be non-toxic to prevent the spread of hazardous substances that can cause harm to human health and to the environment. Policymaking becomes more efficient when guided by science. The Innopol project has therefore given focus to both aspects, and it is very relevant to the current environmental challenges that we are facing. So I look forward to the panel discussion on Innopol's work in Tamil Nadu coming up soon. Thank you so much for your attention. Dhanyavad.
May I now request Sri Ved Prakash Mishra ji, Joint Secretary, Ministry of Environment, Forest and Climate Change, Government of India, to deliver the special address.
Thank you, and good morning to all. Good morning, dignitaries on the dais and dear friends. It is a matter of immense pleasure to participate in the event today, organized by with the help of the Norwegian Embassy and other stakeholders. Globally, increased consumption of resources has been linked with economic development. In India, it is in such a phase that we are increasing consumption because for growth that is important. But we have to manage its unwanted outcomes. Okay. Unsustainable lifestyle and consumption patterns have led to an increase in plastic consumption. The consumption of plastic has risen dramatically across the globe, especially in the developed countries. Of course, in developing countries also, but per capita consumption is very different, far less in developing countries. Environmentally sound management of plastic waste is a challenge confronting the society today, for which we are also already negotiating in the INC, in which India and Norway both are the stakeholders, though on the opposite sides, but which we can say. but we have our goal is different, but maybe ways are maybe different, but goal is same. Yeah. Our goal is to end this menace of plastic pollution, because it is as dangerous as to Norway as dangerous to India. So there is no difference. Use of plastics in packaging and single-use plastic is one of the main factors which has driven the growth in plastic consumption. India recently, 2 years back, banned some single-use plastic items, as you might be aware, in some certain categories, in spite of some very strong oppositions. But we have to do something which everyone may not like, but for future of our generations, for betterment of our environment, we have to take some strict actions and steps. Mindful consumption and deliberate utilization, as emphasis under lifestyle for environment campaign, is the key for tackling plastic pollution. In India, we have launched, our Prime Minister, a campaign called Lifestyle for Environment, which says that you can use, because plastic was not 50 years ago. So if we use our traditional lifestyles, for example, taking bag to the market instead of using the polythene or plastic bags. So I think that can help us in this. The Plastic Waste Management Rules 2016, which provides this statutory framework for managing plastic waste, follows principles of 3R: reduce, reuse, and recycle. Okay. And we are also introduced the EPR in plastic waste management in 2022. So we have mandated the mandate, the recycling to be done by the producers. As per our annual report on implementation of plastic waste management rule 2016, the estimated plastic waste generation is 4.12 million tons per annum in India, which is of course way less than developed countries, but still we have to manage it. So what we have to, we did a two-pronged approach to reduce the production also. So we elimination of single-use plastic, which has low utility and more littering potential, more polluting, because it is not used second time. So people just use and throw. Second is EPR on plastic packaging that we have launched, and we have given targets to the manufacturers and producers too. This strategy is being implemented following the whole of government approach. Whole of government approach means all the ministries, not only our ministry, but also the Central Pollution Control Board, Ministry of Industries, MSME, which we call, and Ministry of Consumer Affairs, all cooperate in this our endeavor, including the industry and industry associations. So, in our plastic waste management rules, we have mandated reuse of rigid plastic packaging. For example, paint buckets, that paint buckets that can be reused. That is rigid plastic, so it should not be thrown, use and throw. So it should be reused. We have mandated it in certain categories that companies have to take back and reuse for a packaging. Of course, there are challenges in that. They have flagged some challenges, but at least we have to start. Mandatory recycling of plastic waste, that I've told, and use of recycled plastic content in manufacturing. I accept that there was also a lot of challenges in this sector, but we have mandated that certain percentage of the fresh manufactured plastic materials should be made up of recycled content, not virgin plastic, not made of that petroleum products. And sustainable plastic packaging means sustainable means where we can use paper or something else, we have to replace plastic by that wherever we can use. For example, the small sachets, we have replaced this sugar sachets and salt sachets small with the paper packages. I think because they are very difficult to collect and recycle. Big packets are easy, but small packets are very difficult. So in that case, we can replace it with the paper packets. The guidelines replace use and throw economy with circular economy. As I told you that using of recycled content makes the loop, the circle of circular economy complete. Recycling technologies have to move from downcycling to upcycling of plastic waste. Means they should not be going to landfills, but even new plastic products should be made such that it is recyclable or reusable instead of throwing it. In India, we have 310 producers and importers and brand owners, as we call them, PIVOs. And the registration on our EPR portals is more than 47,000, including the waste processors, the recyclers, and other entities, importers. So our plastic waste management system is by volume is one of the largest in the world. Of course, due to our population also, but we are trying. In 2022, 11.4 million tons of plastic packaging waste has been processed or recycled in an environmentally sound manner. Means whenever it can be reused, content can be reused, or sent to WTE, waste to energy plants, like in cement plants. We have been using in cement plants. So it is energy recovery. So landfill should be our last resort. If nothing can be done, then it can be go into landfills. Central government, state government, and local authorities have taken the steps on moving towards eco-friendly alternatives. For example, biodegradable plastics, we are trying hard for that, replacing the bags with with cloth, jute or paper bags instead of plastic bags. Our Niti Aayog, Ministry of Micro, Small and Medium Enterprises, they are supporting the recycling industry. We are supporting them financially, we are supporting them technologically. Or alternative products are made from biodegradable materials like crop residue, fiber, rice bark, rice husk, agriculture products, erica leaf, coir, clay, palm leaf, cloth, jute. Everything is better than plastic, whatever I've listed. So, because they are self-degrading and biodegradable. So, even so we have, India has supported some self-help groups, the women groups for making these as a cottage industry, as we call this, small, very small industries, micro industries. Our some leading scientific organizations are doing R&D, research and development in this sector. Our Bureau of Indian Standards has notified Indian standard for food serving utensils made of agro-bio products that will replace plastics. The government of India and Norway are working together in a bilateral cooperation project, India-Norway Marine Pollution Initiative, as we have been working on it, and we thank government of Norway for that. The prime focus of this initiative is on reducing marine litter and other pollutants, specifically plastic waste, because everything ultimately goes to sea. It goes to rivers and then it goes to sea. So the ocean is the ultimate beneficiary of that pollution. So we have to take care of that, because marine pollution is very important. The initiative is being implemented through project partners and include political dialogue, technical cooperation and research collaboration. I think last year we had visit, and this year there is proposed visit to Norway for some study, some exposure visit, and we request for some formal invitation if you can do that. For our studies. So we'll send our policy makers and scientists to look in how it is done in your country, how waste is managed. So a formal invitation will help us. Addressing plastic pollution requires science-driven policies and cooperation globally, focusing on behavioral changes. That is most important. As I told you, that if we practice the which was followed 50 years back when plastic was not there, then that is the ultimate solution, using cloth bags and other alternative materials. The government, industry and civil society should all work hand in hand to scale plausible and effective solutions to reduce plastic pollution. I look forward to receiving the recommendations and outcomes of the panel discussion on science and policy action on reducing plastic and chemicals waste in marine environment. Again, I thank you, the organizers of this event, and any suggestions are welcome. Thank you.
Thank you so much. May I request Mr. Amit Love, Mr. Satish Ji, and Professor Paramita to come to the front of the dais. We will be releasing our 2 baseline reports, titled Baseline Report on Plastic Waste Management in Tamil Nadu, India, Perspectives and Pathways, and Hazardous but Invisible, a baseline report on persistent organic pollutants in Tamil Nadu, India. May I request my colleagues, may I, as a token of our appreciation, may I request Dr. Girija Bharat to present Her Excellency Martine Bottheim with a token of appreciation from the Innopol team. May I now request Dr. Hans to present a token of our appreciation on behalf of the Innopol team. We would like to thank both Shri Ved Prakash Mishra ji and Her Excellency Ms. Martine Aamdal Bottheim for delivering the keynote address. We will now go on to the next session, and may I request Dr. Rachel Hurley from NIVA to deliver her presentation on monitoring and harmonization.
Excellent. Thank you very much. I'm very pleased to be here to be able to present to you today. And I'm going to be focusing on one component that has been introduced of the Innopol project, and that is some very recent emerging data from our macroplastic sampling down in Tamil Nadu. So plastic pollution exists along a size spectrum. The microplastic component is much publicized and I'm sure is very familiar as a term to everybody here in this room. It represents the plastic particles lower than 5 millimeters in size. But macroplastic, which is the focus of this presentation, refers to those larger pieces of plastic, the ones that we familiarly use day to day, plastic bottles, plastic bag, these sorts of things. Microplastic gets a lot of attention because of the opportunity for it to enter ecosystems, to be ingested by organisms, and to move through the food chain. Whereas this macroplastic component, much larger items, not possible to enter the ecosystem in quite the same way. But it's still very important to monitor and to understand macroplastic pollution. For one reason, whilst there are some sources of microplastics, such as the plastic pellet shown here, which is specifically designed to be microplastic in size, the vast majority of microplastic that we see in the environment is made up of these complex fragments that are broken down from larger items. And these all derive from macroplastic items. So if we want to meaningfully reduce microplastic pollution now and in the future, we need to understand and then reduce macroplastic pollution today. Out of all of the sources that we know for microplastic, for example, tire wear from textiles, synthetic paint, synthetic fabrics, it is this macroplastic that represents the dominant source of microplastic to the environment, which makes it a sort of an essential component of actually tackling microplastic pollution. It's also the oceans that get a lot of attention. So we hear a lot about marine litter. The reason why we're looking at riverine environments in this particular study is that all plastic is produced on land and the majority of it is used and disposed of on land. And so these land-based sources of plastic are the way that most plastic items enter the environment in the first place. These river systems don't necessarily represent these smooth pipelines to the ocean. They are quite complex environments and can trap plastic as it goes on its journey from delivery to the environment to the ultimate destination of our oceans. And in this meantime, it can interact with riverine environments in the same way as it might interact with marine environments. And these are ecosystems that also require protection from this plastic pollution as well. In terms of the monitoring, as part of the Innopol project, we have been investigating macroplastic pollution at a number of sites in Tamil Nadu along the Kaveri River. So you can see the team we have here. We've been out for the fully fledged campaigns last November 2024 and also this February. We actually took the last sample from this most recent campaign on Saturday. So you guys are getting results that are hot off the press and are the sort of exclusive results from this second campaign. And we have the team here as well, which includes representatives from NIVA, SRM University, Mugama, and CIPET. There is no single method that can effectively capture plastic pollution at any given place in the river. This is because plastic pollution is dynamic and river environments are complex. At any given time, plastic may be stranded or moving in the river channel. To understand these different dynamics, we need to combine several different methods to get a holistic picture of plastic pollution at a site. So we used 3 different methods as part of the Interpol projects. We use a visual observation for the floating macroplastics that we can see moving along the surface of the river for the full river width. We then combine that with net sampling to understand what's going on deeper in the water column, what we can't see. And finally, we include some riverbank surveys to understand the density of plastic that is stranded along the riverbank environment, which may be picked up and moved along with the river as the water levels change. Moving right into the results, I'll show first the fresh results we have here for macroplastic flows in the river. So this is what's moving along the river that we've measured with these 2 techniques. You can see the 2 sampling campaigns here shown in red and blue. What's notable is already we have this site in the middle that is a huge peak compared to the rest. This shows already that urban environments, this is actually taken from the center of the city of Trichy, represent an important source of plastic pollution to the rivers. At the other sites, the level of urbanization was a little bit lower, so we see that this human presence and interaction is actually a dominant source of plastic to the environment. Something that we also thought we would see more of a difference, but did not, was between these 2 sampling campaigns. So in November, there was higher rainfall, and more recently, February, it's been a drier period with much less water in the river. But actually, we don't see much of a difference across those other sites between those 2 sampling campaigns. So despite the fact that the water levels have been lower and the rainfall is reduced, which limits the amount of surface runoff to the river, we still see similar levels of pollution moving along in the channel. Also, something to note is that as we move downstream, so further to the ocean, the levels actually decrease. You might instead expect the levels to increase as more and more sources accumulate along the river. One possible reason for this is that the Kaveri is dammed at several places along the river. So plastic pollution is trapped behind these dams, which are then opened, and there's a flush of plastic. And the nature of this is very episodic and hard to capture. But it shows that plastic is often accumulating at different points in the river system, and that these rivers are indeed complex systems that do not efficiently transport plastic to the ocean, but instead are trapped at multiple stages along that complicated journey. Moving now on to the riverbank data, we see a less clear-cut spatial pattern here. This is in part because riverbank environments and river morphologies differ quite a lot from site to site. And this geography is something that's very important to consider when interpreting results. What we also note is that the levels are actually a little bit higher in the February campaign that we recently completed. And this is indicative of these water levels being lower, where the water is filling up less of the channel. And a lot of these plastics are stranded along the riverbank, where they've been left by these sort of subsiding waters. So what can we actually take away from this data? I've got 3 main points that I'll take you through now. So first of all, I'll talk a bit about the dominant categories that we saw. These were plastic bags, sometimes empty, but often also with contents tied up. We saw a lot of food packaging of different types, sachets, that's food sachets, cosmetic sachets, and other types of sachets, and then also packaging for cleaning and cosmetics. So what we can take from this is that this is likely derived from household waste. So these are not single-use plastics that are used, for example, for food containers, cups, cutlery, things like that. These are items that are used in the home. And what we actually saw quite frequently as we were visiting these different sites were active dump sites that are in close proximity to the river. So you can already see in this picture here that we have this dump site that is right along the side of the river. So what we can take from that is that in some of these locations, the current solid waste management practices for this municipal waste is likely to represent a source of plastic to the river environment. Secondly, we also made several observations about human habits and behaviour. I already pointed out that very dominant peak in Trichy, where we see that urban environments are linked to higher levels of plastic pollution. But there was also more kind of smaller scale interactions and behaviours that we noted as we were doing these 2 sampling campaigns. First of all, as we were on these bridges, taking these measurements, we observed several times people stopping their vehicle and discarding bags of plastic waste into the river. And in some of these measurements, this represented all or most of the plastic that we actually recorded in those visual observation measurements. So this massively sort of outpaced the actual flow of the river, the plastic that we were seeing already moving along. This represented the dominant source at those sites. There's also some sites where humans interact a lot more obviously with the river. This was particularly the case for some of the upstream sites, closer to Kumbator. Here we saw greater prevalence of clothes washing and bathing in the river. This was going on all morning throughout our measurements. And what we saw here was a sharp spike in packaging related to these activities. For example, sachets for shampoo, containers for clothes detergent. So these activities that occur sort of in the river, along the riverbanks, also represent this source of plastic to the river. And finally, to end on a slightly more optimistic note, we can also make a comment about the single-use plastic ban 2 years ago. Of all of the plastic items that we detected across the 3 methods, only 1.7% of these represented the items banned in that SUP ban. So this indicates that there is good compliance, especially in Tamil Nadu, although it's important to note that we didn't monitor prior to the implementation of this ban, so we don't have monitoring data to show the picture beforehand. So we don't know how bad the pollution was before this ban took place. And also, plastic bags with different thicknesses are obviously included in some of this legislation. We didn't measure the thickness of the plastic bags in these methods. Often we're observing them floating past. So we can't comment on whether there was compliance in that regard, where plastic bags did represent still a dominant category of plastic that we saw in the river. But we can take from this is that some of these legislative measures, for example, single-use plastic bans, may have a meaningful impact on plastic pollution levels that we see actively moving along and stranded along riverbanks in the Kaveri River. And with that, I would like to thank you very much for your attention.
Thank you, Rachel. May I now request Professor Paramita Chakrabarty from SRMIST to give a presentation on persistent organic pollutants.
Thank you very much. It's a pleasure to be here today and give away some of our findings, very snapshots. And I must say, like, we are a big team. I don't know what happened to this picture, but yeah, like the entire teamwork. So I will be presenting some of the very few findings here. And I think Dr. Rachel made a place, and we have some linking with the chemicals, with the plastics. So, you know, as she was mentioning just now, that the issue is with different kind of plastic products that ends up along a river bank. And also another thing is we dump and we do burn them. What happens is, like, major chunk, what we come up with is the mismanaged plastic. I think in Asian countries, India, China, we are ranking the maximum one with the mismanaged plastic. And this activity is still being practiced, and we need to understand that better. What happens? Whatever plastics that are coming up, it's not just the plastics, but the chemicals inside the plastics that also has to be taken into consideration. There are a variety of chemicals. It could be plastic additives, some of the contaminants, and sometimes when we are burning them, some byproducts might be produced. Those could be even like dioxins, furans, can be even more harmful. So this is a common thing, what she has observed along the river, and we are seeing a similar thing with the chemicals coming in, possibly from the plastics. And this is a scenario, I would tell you, like after the pandemic. During the pandemic, we all were talking the water quality, air quality improved. But is it improving in terms of microorganic pollutants? Possibly not. And you see here I marked with red colors. These are another add-on plastics, which in the urban sector we have it more. That is personal protective equipment related plastics like masks, hand gloves, they were more. And we have indicator of the chemicals that can come out of the mask in a couple of our work that we did under this project. So this practice, you know, these are rivers from different areas of the country, just to give you a snapshot, along with Kaveri, that we are dumping and then we are burning the materials, and many times not with just single-use plastics. So from the Innopol phase 1, and we took it to Innopol phase 2, the way forward is like we all, the entire team, we had this paper where we came up different kind of waste. It could be not just the dumped waste, but the electronic waste, and even the marine litter, the biomedical waste, which are ending up, and how do we handle them can lead to a lot of chemicals that may come out. And I even say it all the time, it is a cocktail of chemicals that are coming out, and they are, many of them are endocrine disruptors in nature. So it has severe health impact. So leaching of the plastic litter or open burning, we highlighted as 2 prime sources which these chemicals can come out. So what was our research design? Yes, we did a major chunk in Tamil Nadu. We had a brief understanding of different rivers and then extensive work on Kaveri. Along with that, we had a small work in Uttarakhand. So what we quickly did, we deployed this passive air samplers to track the atmospheric pollution, and especially with this persistent organic pollutants. And we will try to show you a little bit of the data, what we have done. And the idea was, like we covered the entire stretch of Kaveri, starting from Hogenakal Dam, the meeting point after it reaches the Karnataka state, to Bay of Bengal. And some of the marine or the wetland samples were also considered, just to compare and see whether it is acting as a sinking point or not. So what the idea was, we will do surveillance, we'll do modeling. We also took fish samples. There was also bovine milk, some data from that as well. And we also tried to have this interlinking of the plastics and the POPs and look into the risk factor. That was the research component. In addition, we were also going for training, capacity building, of course, capacity building of us as well. I will show you one example on that. And a lot of outreach with the community, getting engaged with the community. So the experimental design, of course, I'm not getting into the complications. Several compounds done, including the 7 important compounds that were enlisted by Ministry of Environment, Forest and Climate Change, and including the pesticides and the brominated flame retardants. And also we added this time PFOS, which is very, very important now. And several samples, atmospheric samples, surface water, surface sediment. We also tapped groundwater for PFOS and fish samples wherever we could get in the river belt. And yes, high-end instrumental analysis. So we all were a part of 2 sampling campaigns. We did the seasonality. I tell you, this is the first time we captured in the country a seasonal data like this for a pool of this huge number of chemicals, 81 compounds and even more. And with this, what we did, I will try to show you some prelim results. So first is, I think there are some researchers here. You will understand it possibly. See, when we do analysis, just one example I would give. For PFOS, method development is so challenging. So when we were working with Dr. Sizzle and Kina from NIVA, one we identified is PFOS was there. The blank that we are using from RO water or the millipore water we are storing in plastic tanks. So lab, understanding the PFOS in the lab is something that we are actually now working on another paper on it. So it's very interesting to understand that. How do we understand the quality assurance, quality control of a data set? So that was very, very good experience for all of us. So a little bit of the data. What we saw is this data doesn't include the DECA BDEs. We wanted to do DECA BDEs, which is not enlisted under MOFCC because, Chennai is the automobile hub of the country, and then, a lot of DECA BDEs are still being used in the casings of the vehicles. So here the data is excluding DECA BDEs. However, in Kaveri, which is a free-flowing river, unlike Adir and Kuvam in the Chennai city. So the concentrations that we saw, excluding the DECA BDEs, the polybrominated diphenyl ethers, which we shortly say PBDEs, in the river, it can be compared. But however, we saw earlier in Tapi Daman-Ganga, which was close to the industrial sites, much higher levels we could see. And in terms of PFOS, we could see this short chain compounds, PFBS and PFBA, because PFBS is actually more even in the groundwater samples, which we have not reported here because we are still going on with this analysis. What the one reason could be that this is a substitute for fabric and electronics. So we are seeing these chemicals coming in. And I must say, what actually Rachel saw, like in Trichy and certain areas, not in the upstream, actually the concentrations are higher. And there are a lot of industries along the Noyal River, so where we are seeing more of these chemicals. Now coming to that sampler that we deployed, for the passive sampler, both in Uttarakhand and Tamil Nadu, we could see that, you look at the atmospheric PBDs level, that Tamil Nadu, if you see the median value, except for some of the very high values, the median value is somewhere little lesser than Uttarakhand. Now see, look at the factor, why? So we did some modeling of this, high-split Lagrangian modeling, and we tried to understand where is the air mass coming from. And all the time, Tamil Nadu is a little blessed, even compared to Delhi. Delhi is a landlocked city, so the air mass doesn't get cleansed by the ocean environment. So oceanic air masses, if you see here the clusters, over 50% of the clusters are traveling from the ocean and then entering to the site. So we can say there is cleansing of air mass in Tamil Nadu, or whereas if you see here in Uttarakhand, the air mass is all landlocked. So it's coming from the land-based. So whatever sources are there, the device can capture those chemicals. So with that we can understand. And there was some data we did, the prelim data before the project started in Chennai city, because we had a lot of data from Chennai. So the PVD levels, the flame retardant levels are increasing, like over 1.5 decades. It's actually on an increasing mode. So we need to understand that better. So atmospheric emission is one factor. But again, with the rainfall, because nowadays Tamil Nadu's last couple of years, rainfall was very high. So deposition comes in the river. And then as it is washing out in the open ocean, we are trying to understand how these things are happening and how we are still doing the modeling work. And as I told you, we are not only restricting with the lab, we are the team, we are reaching out to the community, trying to understand what is happening, especially when there is flood, and we are trying to reach out, do a lot of outreach event, including some of the outreach even jointly with the Norwegian embassy and all the partners of the group. And we are reaching to the people, trying to understand, people are still using plastic vessels to store the drinking water. So we are trying to make them aware of these problems, and many a times, hot summer month in Tamil Nadu, it's like nearly 40, 45 degrees, and we have leaching experiments showing these chemicals can leach out from the vessel to the water, so the water that we are drinking. So this kind of awareness campaigns are very important. And we are also working on a very cost-effective technique, which we named as Mantra Pod. We are using a very interesting set of model, which is the plants on the top, a nano filter bed, and with a lot of indigenous microbes incorporated in, and trying to understand this better, because these chemicals are in parts per billion level. So we cannot do normal traditional removal techniques. So this is what we are doing, capturing a lot of sustainable development goals. And I must say, and thank the embassy for the support that all the partners institute we have got, and we have come together. Thank you very much. And I feel like I could give some message from our story. Yeah, thank you.
Thank you so much, Professor Paramita. We now go to the next line, which is our panel discussion, which is going to be chaired by Dr. Girija. May I request my colleagues to help with the changes? May I request Vilde and Satish ji to please join us. May I also request our colleagues joining in the panelists online to switch on their videos. Dr. Girija? Rachel and Paramita maybe can also join us here.
Thanks for being here and showing your interest. We had wonderful presentations and great insights from our dignitaries, Mr. Ved Prakash Mishra and Her Excellency Martine. Now we have the panel of eminent scientists, researchers, and policy makers. We have Satish Sinha. He is the Associate Director at Toxics Link. Vilde has been with the NIVA and working in the plastic sector for several years. I have requested Professor Paramita and Dr. Rachel also to join because there may be some questions related to your presentations. This project, Smita Mohanty, Director of CIPET, has joined online. She was unfortunately not able to join us. Avanti, the Associate Director of Imugama, has also joined online. So we have 4 panelists and 2 presenters. This project, Innopol, has been not just a project for us, it has been our passion for several years now. We are trying to generate science-informed policy recommendations for the government of India. We hope these recommendations don't just remain in these reports, they are utilized and utilized for the betterment of environment and society. These reports have been having, we have the soft copy of this, we'll be sharing it with all of you, we'll be putting it on the website as well, and few copies are also available, hard copies will, Under Innopol project, we have first worked in Gujarat and now in Tamil Nadu, and the insights which we saw just now from the presentations of Paramita and Rachel have been really very interesting. So we have been focusing a lot on the hotspots or the issues, but not just that, it doesn't remain there, it is also solution, what remedial action, what mitigation plan do we have? As a country, as a research society, we have to focus on that. So with the background which we have in this project, I thought to ask a few questions. Satish ji, you have very long experience in this area. So given the documented evidence of increased occurrences of plastic additives, Paramita had mentioned about the POPs and plastic interlinkages. So these plastic additives in both consumer products and the environment, how can public awareness and education play a role in minimizing the risks associated with these toxic chemicals and chemical products? Over to you, Satish.
Thank you. That's a very, very interesting question about public awareness and how does it help in trying to remediate some of these issues. I think the issue about chemicals in plastic, this is a gap area that I understand mostly because there is an inadequate understanding about chemicals in plastic. Mostly. I wouldn't say that it is prevalent across, but that is largely a gap area in communities and citizens. The second important factor about plastic is also that we mostly tend to see plastic as a litter. The problem is that we see it as a litter. So these are 2 important considerations before I talk about plastic and what awareness can do. And this project that we are progressing with, it clearly establishes one factor that you have more plastics, you're likely to have more contaminants which goes into different mediums. Like she has tested on water surface and rivers, Rachel pointed out, I think Paramita has pointed out, there is clear-cut evidence that you will have POPs, you will have other kinds of chemicals which usually leach out into the medium through which it moves or travels or it is used. So it's important to understand this part of it, which is very rarely understood in complete clarity and honesty. It is something that we do not know very well. And what are these chemicals? How do they impact? The second point to understand also is that most of these additives are loosely packed, they are not chemically bound. And that is why they get released whenever there are external forces or actions which take place with plastics. So these are a couple of complexities about plastic. It is not at some point of time, we all together that plastic is the most inert material and is absolutely safe to use plastic. Well, today, as science moves forward, as there is more data, as there is more evidence, we get to understand this. Some of these chemicals are very, very complex. They are known as the most complex chemicals that we all know, especially about POPs. She's talking about PFAs, HBCD, diphenyl ether, all these compounds that she's talking about which is packed in the plastics as additives to give it different kinds of properties. They are extremely dangerous and they have different kinds of toxicity. Many of them are absolutely hazardous and they're actually globally regulated under a convention. There is another set of chemicals which we realize now in plastics, very extensively used, is the endocrine disrupting chemicals, which have not been regulated under any framework or any regulation so far globally. And they continue to be used very, very extensively. And maybe there are some national decisions or national regulations which each country based upon its practicality, its affordability, its research capacity. They have put some mechanisms in place to control or to monitor or to regulate some of these. And essentially, the objective is to protect human health and the environment. So those are the conditions which are there. Now, this kind of data that we have, and that's very important, critical for raising awareness, because unless you give empirical data, people find it difficult to believe what is actually happening. If you just say BPA is there in plastics, he says, how much is there? What does it do? How does it work? I don't know. Does it get released or does it not get released? Is there a leaching test that you have done? So, all these kinds of, so what does data do? Data fills this gap of knowledge gap. And this is very, very critical for people to understand that what can it do. The second thing is, it makes manufacturer a bit more responsible because people are asking questions because of this data. So there is a certain amount of responsibility which goes back to manufacturers and producers. Because one thing about chemicals in plastic is there is a lack of transparency from the manufacturer side. You will not find what all chemicals are there in this packing or in the manufacture is very rarely seen. So labeling and transparency are two issues which are very, very difficult to find in plastics. Over a supply chain, over its complete life cycle that you'll see, you'll not find this. It's a difficult place to be. And I think what again this information does or awareness does, it places a pressure, it gives pressure on some of these things to start improving. So these are upstream changes that can be made and that can be influenced. The third thing that it can influence is labeling. I think it's important to understand when you use recycled plastic, how safe is it? So if you have that kind of knowledge, so what awareness can do, if I create an awareness in the community that only if you see A written on it or B written on it or C written on it or X written on it, you can use it. So any symbolic description of a plastic makes it so simple for everybody who is not even knowledgeable, who doesn't know plastic, but he can see this symbol and say, oh, it is safe for me to use it, or give it to my child, or use this plastic toy for my child. So these are all things that really can push. It also makes a push for policy discourse. If consumers are aware, if consumers know about it, it does put a pressure on policy intervention, and there will be different kinds of regulatory incentives, could be non-regulatory also, it can be voluntary approach, it can be producer's responsibility, it can be multiple things can happen because of the kind of information which is put out in public domain. So that's some things that I feel it is a great help to create this kind of information and bring awareness through this kind of data, research, and researched information with certain amount of scientific evidence is really the crux of the whole thing. Thank you.
Thank you so much, Satishji. That was very interesting and elaborately explained answer. Smita, I would like to hear from you. You must be happy to hear that Rachel mentioned we have less frequency of single-use plastics in the Kaveri, the recent campaign which we saw. So addressing the plastic pollution issues, which requires a system-wide approach, and how do you see India progressing in this direction? Especially you have been working in the single-use plastic, EPR rules of India. So what is your thoughts?
Yeah. Thanks everyone for giving me online link. Now, currently I was actually attending the 3-hour circular economy conference at summit at Jaipur. I'm a part of it. Now, what we can see is that yes, we have progressed ahead with managing the waste because some of the policies have been developed. You can check that EPR portal has been developed. Specific standardized EPR portal has been developed now. So the number of plastic waste producers, you can say processors, PWP, so far you can see every day they are registering and government has made it mandatory. So far, I think as on date, around 2,700 PWP have registered, and they have been given targets. Each industry has been given a target of your extended producer responsibility, pay polluters principle, which needs to be, of course, it needs to be monitored, and CPCB is playing a very vital role in assessing that how much quantum of plastics is being generated and how much they are using the recycled content, and other audit like mass balance audit is also being emphasized so that the certificates are generated and online certificates are generated based on that. As regards to the single-use plastic products, yes, 19 categories government has banned. They have put a ban on certain items that you are not supposed to use it. What we still find is the carry bags. And of course, the the micron size has been increased from 70 micron to 120 microns. So with a subsequent, I mean, with emphasis that these can be subsequently recycled and this can be converted into some value-added products. Like today in the morning session, it was highlighted by government MOEF and CC that they are putting much emphasis on use of these recycled products into a lot of upcycling, not for downcycling. Like when we go for any downcycled products, there are chances of migration, there are chances of other issues. Where we can use the upcycled products and how we are utilizing the upcycled products, there requires some of the scientific background and scientific inputs, how to technically process it and how to go for, going for upcycled, recycled products. And whether these kind of recycled products, what is the application sector you are targeting? It should not be that only one thing we should target only for packaging applications. There are other manifold applications which you can target it, which you can go for it, and those kind of targeted applications needs to be focused where you are exactly using it, whether it is directly coming in contact with body or it is directly impacting the human health. Those things needs to be assessed. So these are some of the practical observations. Yes, when I see here a lot of Asia Pacific countries have participated. There are a lot of breakout sessions also in Jaipur, this 3-hour economy. What I find is we are progressing because we have a portal which many of the countries they don't have. EPR, we have made it mandatory. Certain restrictions are being raised. If you can see, the regulations has raised restriction on the compostable as well. They have to enter into EPR. Biodegradables as well to enter into EPR. So these are the certain kinds of government initiatives they are taking. And at the same time, analysis methods for microplastics is also being taken into consideration because being a part of the standardization committee of Bureau of International Standards, Indian standards, we are following up and we are also adopting the ISO standard for evaluating the microplastic content in the soil, in the sediments, in water. So these protocols have been adopted by BIS, and the regulation is also PWM regulation. Also, you can see there is a mention of microplastic assessment in each category, whether it is a compostable one or it is a biodegradable one. So these are certain progressive steps which Government of India has taken, and slowly, a lot of other things are also there, like integrating the rag pickers. Along with the management, those initiatives are also being taken care in the current scenario. So that is the thing which we notice.
Thanks, Smita. That was interesting. Yeah. From national to the global context, Vilde, you have been part of the INC process. You have been attending the INC meetings. for the Global Plastic Treaty and your experiences with international monitoring protocols. What are your reflections?
Thank you. Can you hear me? Perfect. Yes, as you mentioned, I've been very fortunate to be able to attend the INC process and the negotiation rounds for a global plastics treaty. And it's been very interesting to see how the research that we do can fit into such a global perspective. Monitoring programs can tell us effectiveness of policies that have been put into place. And Rachel has talked you through the methods that we have been using. And we see we've been doing similar methods in, for example, Vietnam. And it's been quite interesting to see the differences in pollution that we see there compared to what we've been seeing through the Kaveri River. It's already been mentioned several times today that India did put in a ban against certain single-use plastic items, such as straws, cutlery. And like we already mentioned, we've seen very little of this throughout India, but that has been a very dominant source that we have seen, for example, in Vietnam, where such a ban hasn't been put into place just yet. Another thing is, of course, that putting in monitoring programs will need local adaptations. No river is the same. We have had, which we have experienced throughout our trip in Tamil Nadu. So being able to adapt to local conditions, having local knowledge with us, also in identifying different types of plastic items that we might see here, but we potentially wouldn't see in a different state, or of course a different country. And also just to wrap up on a global perspective, the chair released a draft text at the end of the INC 5, which was agreed upon to be the working document for a plastics treaty. And in that document, monitoring and establishing monitoring programs has been mentioned in several options of the articles. For example, identifying hotspots and accumulation zones for plastic pollution, as well as establishing monitoring programs and international capacity building and awareness raising. Thank you.
Thank you, Vilde. Now, Avanti, over to you. A few questions, since you have been working in the area of POPs for several years now, and also working on PFAS. What are the aspects that India needs to focus on with regard to PFAS in drinking water, particularly?
Yeah, thanks, Dr. Girija. Our work on the reduction and management of PFAS in drinking water that we are currently doing presents certain key aspects that India needs to focus on. The first one will be to develop binding national regulations and setting standards to regulate PFAS levels in drinking water. For this, national and international standards, such as those of the European Union and US EPA, can be used as a reference point to ensure effective regulation. Also, incorporating PFAS limits into the existing BIS drinking water standards would be a significant regulatory step. For enforcing these regulations effectively, a comprehensive action, national action plan should be developed to focus on reducing emissions from industries and agriculture. It is also necessary to mandate regular PFAS testing in municipal and private water utilities. For this, a national PFAS monitoring program is necessary to track contamination trends and identify pollution hotspots. Next, comprehensive research is needed. A lot of research is going on, but comprehensive research is needed to identify and characterize PFAS pollution sources in different environmental matrices. Then a national PFAS contamination map that would be really helpful in the lines of what the United States has done. It can provide critical data on affected areas, pollution hotspots, and at-risk populations. It is also critical to invest in water treatment technologies and strengthen the technical capacity at the local and regional levels to improve testing and mitigation. Another important aspect would be to partner with like-minded global organizations that can help India adopt best practices, access new technologies, and strengthen PFAS management strategies. Lastly, For industries, stricter regulations will limit discharge on PFAS-containing products, and transparency in PFAS usage reporting should be mandated for manufacturers and importers. A phased approach with incentives can help encourage industries to transition to safer alternatives. So by implementing, we believe that by implementing these measures, India can effectively regulate PFAS pollution in drinking water sources, protect public health, and strengthen its overall water quality management system.
Thanks, Avanti. Yeah, in fact, we have been also involved with Government of India Ministry of Jal Shakti, National Mission for Clean Ganga in wastewater reuse. And these aspects are very important because reuse water, we think it is like it can be used for reuse for any purposes, but it's not. We know the contaminants that gets unchecked in the treatment plants. Our treatment plants are not designed for treating to this level of accuracy where we can reuse it for potable purposes or groundwater recharge, or for that matter edible crops irrigation. So working with different ministries, we have these insights, and we are also able to influence policies in several states like Uttar Pradesh, Uttarakhand, and few other states in India, where they are preparing the policy and we are part of the policy process, and we are able to give our insights from this project particularly, so that we are having safe systems in place going forward. Some questions I would request the audience to ask Rachel and Paramita, and if we have question time, I'll ask some more questions to the panel. Sir. Yeah, Sumit. Yeah. I request you to kindly introduce yourself and mention the speaker to whom this is.
This is Sumit Sharma from United Nations Environment Program. Thank you, Dr. Paramita. Very excellent, brilliant presentation, and a lot of very analytical work which you have shown. Just one question on, you have shown, POPs levels in different, rivers and all that. The question is, do you also would like to compare it with some sort of thresholds, or with information from other parts of the world to make a context of where we are at this moment? We see levels high and low within India, but we are still not getting the picture whether it's good enough, bad enough, or where we are. So just a comment on that. The second thing which you mentioned regarding the comparison between atmospheric concentrations of POPs between Tamil Nadu and Uttarakhand. And despite the dispersive conditions existing near the coast in Tamil Nadu, your chart shows higher values in Tamil Nadu. And so any explanations for that would be required. One question for Rachel. Rachel, again, you mentioned that 1.7% of SUPs are found. So 1.7% of what is something which I want to understand. And you said it's low. Have you compared it with any baseline to make that statement? So these are the two questions. Thank you.
Thank you, Dr. Sumit. I think that's a very important point. We are trying to capture the compositional profiles, understanding in what way this distribution pattern. So this is just a prelim data. We have not all the data in hand. So what I showed is a very prelim data. We also need to understand that the chemicals that we are analyzing, how it varies not only across the globe, but within the country. And believe me or not, during this last 2.5 years, we are actually capturing data multiple times. So soon, once all the data are in, I think next year WSDS, you will have a very, very clear picture. What is in terms of seasonality, or in terms of the source sinking regions, and the compositional profiles. That is in particular. Like for example, we saw more of PFBS. This is very unique when we are comparing with other data across the globe. What you saw was an average chemical concentration, and which most of the other people have done for the same set of chemicals. So that is what we are still waiting, and that would give a very, very clear picture. And your second question was, yes, as I was telling you, the box plot was showing the range. Yeah, there are high concentration areas near the industrial areas. It was mapped all along the Kaveri bank. And then especially the Noyal region, where the industries are there, we could see some outliers, I would say. But when it comes to the average concentration, when we compare, just if you see, the average would come down at around 20 to 30 nanogram per meter cube. That is for PBDs and not the DECA ones, of course. So these shows that even though some sites are showing high concentrations, but there are, as you go downstream especially, and then it is for the air mass is not very localized. When we do this modeling, it's like cleansing the air mass. So holding capacity in the air is also possibly less. So which is why I think the rivers become even more important. So these are the two factors that I hope I could answer you. And I'll pass to Rachel for her question.
Yes, thanks for your question. So the 1.7%, that represents all of the items that we collected across the 2 campaigns in November last year and February this year, including what we counted in the river and also along the river banks. By count, 1.7% of those were these... Only plastics, yes. So that 1.7% represents these single-use plastic items. It doesn't include those plastic bags because we didn't know the thickness of those. We weren't able to measure those. A lot of this is visually surveyed from a bridge, so we can't measure thickness. In terms of the comparison, we can already say that this is not a dominant source based on the other categories that we find. So we find other categories that represent, for example, 10, 20, 30% of that plastic pollution that we see across these different sites and within the sites. But we can also compare this to other countries where we have been monitoring. So myself and Vilde have been also working on a similar project in the ASEAN region, where we've been deploying the exact same methodologies, those 3 different methods that we described, some small adaptations to adjust to the different river conditions, but all in a way that is harmonized so we can compare the data. And we see in Vietnam, also in Cambodia, Indonesia and the Philippines, we see a much higher proportion of plastic pollution represented by these items. Yeah.
Thank you, Rachel. Yeah, some more questions?
Yeah, I'm R.N. Jindal, former director of the Ministry of Environment Forest, and then followed with the executive director of a company dealing with chemical hazardous waste. And I worked with the Swachh Bharat mission also. Presently, I'm independent director. I have experience of Stockholm, Rotterdam, and Minamata conventions, and have been co-lead for these conventions. My only brief inputs are, when polymerization takes place, when we are making plastic products, so it could be exothermic, endothermic. We are using various chemicals, PFAs, PFBs, PFBAs. How they remain in free state? They will be when chemically mixing and polymerization is happening, if everything is in free state, and how long duration they will continue to be released in the water or the atmosphere. Second, because these are the basic. Third is when you are putting analysis result, is it the peer-reviewed results, and have you standardized the? I'm not questioning you, but I'm just getting my information with the NIRI and CPCB, the methodology, because it depends, when you are dealing with the PPB levels and less than that. So how much is the accuracy of the results? Because sometimes it creates sensations in the, media that, such things are being in the water and everywhere. So those are the, if you can kindly throw light on that. Thank you.
Yeah, actually, whenever we are analyzing any chemical, first of all, we need to use the standardized USEPA methods. And secondly, we are done inter-lab calibration between NIVA and our groups. That is one thing. And we have published so far, I don't have the count, over 100 peer-reviewed papers, very high-end journals. And many times, this peer review is all the international journals. So I think whatever data we will have now, we will also come up with the standardization data that where we have done between the labs, and we believe that there will be some kind of authenticity with the data.
Thank you, Paramita. And also we are generating data for the awareness of the citizens, primarily of the policymakers, because if there is no awareness, then action cannot be taken. But people should be aware, because what we are consuming, what environment we are living, if we are not aware of it, if we are not taking corrective action, then we are getting into a more public health hazard situation. So I think it is very important that this coherent data is communicated to the relevant stakeholders and when required to the people as it is, without creating sense of what you say, discomfort or people, hype. It is real data which is speaking the truth. The exposure, yes, yeah. Get your point, yes. We have few more questions, Swati. Yeah.
Sure. I'll keep it brief. First of all, congratulations to all the partners for putting such high impact work on around research and data. A very basic question on how were you able to cement all these learnings in terms of subnational strategies or policy level, and what have been the learnings in terms of taking this up to government stakeholders? What kind of reception did you see? And how do you plan to take this important research benefiting other countries in the region, specifically South Asia, because these are important learnings that could be replicated. So could be Rachel or Paramita or Satish.
Thank you. I think that's a very interesting question to ask, that how does it get taken forward? I think there are various ways of taking it forward, and we are doing that slowly and gradually. I think all these are being shared with the policymakers. There is a policy brief which is being presented to them, and that's why you find the ministries and other government which are present in this. Their industry presence somehow is not there today, but industry is also fully aware of many of the findings that we're having on plastics, and they're fully aware of all these components of EDCs and POPs. Well, I am sure that many of these will get taken up slowly and gradually, and there is a process and there is a time also period which it will take to make these changes happen, and that depends on many factors. It is not that just because you found this chemical and this resin core, do we need to change it immediately? They are being replaced, they are being changed, they are being looked at. Like, I'll just give you an example. We had BPA in feeding bottles, child feeding bottles. Children, they drink milk and you give them this, and then you had in sippy cups, toys. You had all these chemicals in all these things. Now, it is because of the research, it is because of the data, it is because of the awareness of citizens and the ministry both, that many of them got moved out. They have been eradicated. You will see that there is a BPA free. There's a regulation by the government of India that you can't have BPA in feeding bottles. You can't have it in sippy cups, and so far, and so other chemicals too. I think this also has a process, and we are part of that process, and we are moving it with the respective stakeholders. And I think, and as part of the process and part of capacity building, we're also discussing this with the regulators. We are doing capacity building of the regulators, how to test, how to monitor, how to understand this, because that was lacking. And this is how this is to be taken forward. So there is a process, and we hope that some of it we will be able to take forward. Thank you.
Thank you, Satish ji. In fact, through this project, we are building capacity of several stakeholders, several groups of stakeholders, online, offline, and in the field. We have been taking Pollution Control Board colleagues to the field and showing them how to collect sample, how to do the instrumental analysis. So it's a complete set of in-person training, which is in field as well as in laboratory and online, to understand the background of it. So one last question, if I may just give to you. Yeah, please.
Very nice presentation by both the speakers. Let me introduce myself. I'm Ankur. I'm working as an associate fellow in TERI. So I don't have any question, just I want to supplement the answer regarding what Sumit sir asked. the reason for the variation in the concentration of different POPs. So basically, there is a log KOW value, which is the octanol water partition coefficient. So it depends what kind of matrix and what kind of contaminants are we targeting. So the concentration of any particular POPs or any contaminants depends on a log KOW values, which vary. Like in case of polybrominated diphenyl ethers, when you go, you see like it is having 209 different congeners. Like the top is the DecaBD. So it is having higher log KOW value, approx 7, 7.5. While you come for tetra or some lower congeners, it is having less log KOW value. So it depends on the method as well as the contaminant which we are targeting. And the second question, sir, which you asked, like till how much time the chemicals are being released. So, sir, basically the chemicals which are being added to the plastics. So, it just the polymeric composition will you see. So, the chemicals are being released through the entire life cycle. So, like from the manufacturing phase up to, like if we are using proper channel like recycling, so it will be released during the recycling time. Or if we are ending up in the landfill, so it will be released during that time also. And it also depends on several environmental factors. Thank you.
Thank you. Yes. Yeah.
One pointer to add to Ankur is like, sir, you were asking that how in the plastic vessels the leaching. I happen to mention that both we worked for a Research Council of Norway project, and there what we did is we mimicked the plastic bottles that are kept outside in high temperature condition, that how much it can leach out. We mimicked the real-time concentrations in the lab, and we were seeing the polymeric, the bottles made up of recycled plastics, they are leaching out more compared to what we see. And we use the same time frame. Then we model it, kinetics modeling, to see like within a month what is happening. So that
several classes of endocrine disrupting chemicals leached out from there. Yeah. One last question, and then I will give it to Hans, who will say the. Yes, please. Yes, please.
Greetings, everyone. I am a teacher from Delhi Public School, Faridabad. And today when I attended, this is my second session. Having attended it, I feel that we are talking about numbers, we are talking about research, we are talking about a lot of data. I look forward to bringing all this down to school level, where children are involved because they are the ones who are going to make it further, right? So, we at school look forward and rather have the Swachh Bharat Club at our school. We have the Sevam Club at our school, which looks forward to helping and working for environment, animals, and mankind, you know. So I would rather propose if children at school level could be involved into such researches, could be given a first-hand experience, I think it'll make a difference. And if children get such internships or even if just involvements, because we have given first-hand experience to our children already. So DPS looks forward to such opportunities where children get to learn and we bring it down to their level so that we work on this issue, on these issues at the basic level. Rather than, you know, creating it, let's stop doing it from the base level. So that's my suggestion, a proposal. Thank you so much.
Thank you so much, and really well taken. Children are the change makers, and we really appreciate your intent of bringing this, connecting the stakeholders, all of us. And we'll be, in fact, some of our research, we are focused on children's health. The research which Paramita was mentioning, this was undertaken in 2018 to 2022. It was under Research Council of Norway's support, and we brought out several classes of food. Our food plate has some of the food items which are very high in endocrine disrupting chemicals. Sorry to say that. Some of the dairy products, some of the non-vegetarian items, they are very high on these chemicals. And we'll be definitely interested in mobilizing children and garnering their support and interest, because they are budding scientists of the country and worldwide.
I would just like to add on to this. As I told you, my children are really aware in these terms, and we have a lot of you know, activities, and a lot of things that we do and take the children out. So in terms of collecting single-use plastic, not that we are promoting create waste, but we were the ones to collect 100 kg of single-use plastic and give it to the recyclers. And the Municipal Corporation of Faridabad identified DPS Faridabad. We were the ones who were rewarded for, collecting and helping the recyclers in and making the proper use or reuse and the treatment of the same. So that is the reason I look forward to,
we will connect with you separately. We will be in touch with you. Thank you so much. And over to you, Nathaniel. I'm standing between lunch and all of you. So yeah.
Hans.
Yes, thank you so much to all of the panelists and speakers. So I'll just very briefly end with some overarching reflections and maybe a little bit of a bird's eye perspective on the work that we are doing. The Innopol project and the partners, we have been working for around 5 years on this subject matter. And one thing that we have to acknowledge and that we also see in our work all the time is that plastic-related research is not a mature field at this point. It's a maturing field, but it's not a field like, for instance, when we talk about EDCs or certain other topics where you can produce, for instance, textbooks with standardized protocols or with standardized methods. So it's something that is still very much evolving, and we are co-evolving with this research and contributing with our findings along the way. You can also see that, for instance, with the plastic waste management rules or different regulatory measures and acts, they are changing quite frequently, reflecting maybe economic realities which are shifting. India is growing very fast as an economy, new industries are evolving, but there's also new scientific research that is coming to light. And this is kind of the entry point for us to really contribute to. And I think also the gentleman who asked the question on leachate and POPs and the health impacts. There is a lot of risks also around alarmist research. There's a lot of questions when it comes to microplastics. What kind of health impacts are there? Should we be really concerned about microplastics more versus compared to macroplastics, which are actually the origin for microplastics? So the point is that we have to be aware of this changing dynamics, this changing context. And also what Rachel, Vilde, and Paro, Mita were talking about in terms of the methods, the monitoring, the sampling. We basically try to adapt everything to a local context because there is no generalized protocol. And the systematic approach is simply born not as an opposition, but essentially looking at Rachel's presentation, for instance, about leaches, municipal waste moving into riverine systems. I mean, it's quite intuitive. But intuitive is not a very systematic way to actually understand the problem. So basically, this is kind of where we move in with the scientific approach. And this is also our contribution to formulating more targeted policy, more targeted regulation. And one point, so we just came, for instance, from the monitoring work along the bridges, and a lot of people asked us, why are you doing this? We can see the waste in the river going in, but our kind of ideas, intuition is good. Intuition we are innately born with acting on intuition, if it's our smell, if it's what we see, but we could be wrong as well. So the kind of approach that we use is essentially a measure to reduce uncertainty, to reduce risks of getting things wrong. And this is also why we do these sampling campaigns and develop localized protocols. And of course, this is the fundamental motivation over the last 5 years. And this is also what we try to attempt moving forward. So I thank all of the speakers, all of the panelists, and all of the audience for your interest. And I would like to give a special thanks to Dr. Girija Bharat, who has really been pulling together a lot of this work with the baselines, but also with this event, together with Terry as an organizer. So thank you so much for your efforts, and thank you everyone for your interest and the great scientific work that you have been doing. And of course, we are available to talk with you also outside of this room. So thank you very much.
We are especially very thankful to the Norwegian Embassy for giving us this opportunity to work on such work of great dimension and great impact. Not only this research is doing this project, but then it is also helping the policy of several states and several government of India's policies, like the National Framework for Safe Reuse of Treated Water, Plastic Waste Rules of India, and of several states. Thank you so much.
Just an announcement, lunch will be upstairs, will be probably in the lawns. In case you don't have a lunch coupon, my colleague Neha is over there, you can collect one from her. Thank you.